All right, so this is Chapter 5, Section 7, the Binomial Theorem. We are going to use Pascal's Triangle to expand a binomial, and we're going to use the Binomial Theorem. Yay! So, super exciting stuff, because I love triangles. Definitely have to write all this down up here. Essential understanding, do not have to write down. You can use a pattern of coefficients to write the expansion of a plus b to the n. So we can expand a plus b to the third using the distributive property where we multiply the first and the second one together, and then that results by the third one, which is kind of time consuming. This is a shortcut to doing the expansion using distribution. So we're going to expand the binomial. To expand the power of a binomial, usually we multiply and then write in standard form. We are going to use a little pattern that we find to make our lives a little bit easier in doing that. Okay, so if we look at, and I do want you to write this little chart in your notes. So if we look at row 0, so it goes with this power, so row and power are the same. A plus b to the 0 power, anything to the 0 power is 1. And then I have row 1, which is a plus b to the 1. That is just 1, a to the 1 plus 1, b to the 1, or just a plus b. If I just write the coefficients, it is 1 and 1. A plus b squared goes with row 2. When I multiply that out, I get a squared plus 2ab plus b squared. If I just write the coefficients, I get 1, 2, 1. To the third power, I get a cubed plus 3a squared b to the 1 plus 3ab squared plus b to the third. If I just write the coefficients down, I get 1, 3, 3, 1. And then fourth power goes with row 4. A plus b to the fourth, I get a to the fourth, 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the fourth. If I just write the coefficients down, I get 1, 4, 6, 4, 1. All right, so if we look at the pattern, so if I look at how do I use 1 and 1 to get 2, you add them. How do I use 1 and 2 to get 3? You add them. How do I use 2 and 1 to get 3? All the outsides are 1s. And all the insides are the 2 above it added together. So let's use that to create our fifth row. So if I have row 5, a plus b to the fifth. So what we're trying to say here is I don't have to actually multiply out a plus b 5 times to itself. We can cut through, we can use this pattern, use Pascal's triangle, and write it. So let's write the coefficients first. The first one is going to be 1. 4 and 1 is 5. 4 and 6 is 10. 6 and 4 is 10. 4 and 1 is 5. And the outside is 1. So when I go to write my expanded form, it's going to be 1a to the 5th, it's the same as the highest power, plus 5, a to the, so the a bumps down 1, a to the 4th, and then the b appears, plus 10, a bumps down 1 more, and b bumps up 1. So this is a to the 5th, a to the 4th, a to the 3rd. So a's are decreasing each time we write, b's are increasing each time we write. And then we have our 10. A is going to decrease by 1 power. B is going to increase by 1 power. So 10a squared b to the 3rd. And then we got 5a. So it goes down by 1, and b increases to the 4th power. And then the last coefficient is 1, and a to the 0 is 1, times 1 is 1, and then b bumps up to the 5th power. So using coefficients only, finding the pattern, we can expand binomials without doing all that hard work multiplying them. So if we expand Pascal's triangle is the triangular array of numbers in which the first and the last number of each row is 1. Each of the other numbers in the row is the sum of the two numbers above it. So, start at the top one. The first row is row 0. The second row is actually row 1. So I want you guys to go ahead and add row 6, 7, and 8 to the previous, this guy. So you guys have already done rows 1, 2, 3, 4, 5, and 0. I want you guys to add 6, 7, and 8. So we are going to use row 8 to expand a plus b to the 8th. And we're going to use Pascal's triangle to put this together. So take a moment and attempt it on your own at home. Okay, so for Pascal's triangle, you want to put the coefficient from the triangle in front of your variables. You always start with your first, so I started with a, and then the first one is always going to get the power that you're raising your binomial to. Then you're going to decrease a, so it went from 8, 7, 6, 5, 4, 3, 2, 1, and then non-existent. And then b goes from no b, b to the 1, b to the squared, cubed, 4, 5th power, 6th power, 7th power, and 8th power. When you guys are putting this in, inputting it into Canvas, into your mathexcelforschool.com, you can actually do powers. For Canvas, you can't. It's just straight whatever your keyboard is able to type is what it'll input. So if I'm putting this in, if I have a power or a coefficient of 1, don't include it. So this would be a caret 8 plus 8, a caret 7, b, no caret, plus 28, a caret 6, b caret 2, plus 56, a caret 5, b caret 3, plus 70, a caret 4, b caret 4, plus 56, a to the 3rd, b to the 5th, plus 28, a squared, b 6, plus 8a b caret 7 plus b caret 8. So that's how you put it in Canvas. No spaces, no powers or coefficients of 1. All right, so the binomial theorem is the theorem that we've been using. We are going to, if we are expanding, the p's are the numbers from Pascal's triangle. And then we start with the a to the degree. So the first guy to the power that we're raising the binomial to, he decreases by 1 each time.
Oh, that's so easy.
And b in.
Oh, like that?
Well, but how do you do the negatives and the 2?
Yeah. So now we have
Decrease
a coefficient of 2.
I know, I think.
So and then the b increases each time. So it's b to the 1
It's
squared.
separate. This time.
Okay. So let's go ahead and do this. Let's find our fourth row from our Pascal's triangle. Okay, so if we go back and look at our fourth row, 1, 4, 6, 4, 1. And the first one, the top row is row 0. So we definitely want to match it with this power. And I know it's fourth row because the second number is going to be the same as the power. That's also another power pattern. So if you look at 6th row, it's going to have a 6 for the second number.
Wow.
I know, tons of patterns in this one tiny triangle. It's huge.
Nah.
Okay, so we're going to put it together. We're going to write the coefficient, although I'm not going to write 1. I will write it just for fun. So coefficient of 1, we are going to take the first term, 2x, and raise it to the 4th power.
Put in parentheses?
I put it in parentheses just to show
You
I'm
put the 1.
multiplying it by 1.
It confused me.
The next coefficient is going to be 4, just so that you guys can match. I did a 1 and a 1 here, a 4 and a 4 here. Then it's going to be my 2x to the 3rd power, because I'm decreasing it by 1. And it's going to be my negative 3 to the 1 power.
I get it.
I don't.
I take my second term, which is negative 3,
I thought I did.
and I raise it to the 1 power. So 2x is my first term. He starts out as 4, and he's going to go to 3, then he's going to go to 2, he's going to go to 1.
Wait, why is 2?
Okay, so the next thing we're going to do is we're going to use this 6.
So it'll be 2 and then 2? Be 2
Uh-huh.
and 2? Okay.
So we throw down the 6,
Wow.
hit our parentheses. We have our 2x, which is our first term or our a term. He is going to be squared because he goes down from 3 to 2. And then my negative 3 is going to go from 1 to power 2. Then I'm going to use my 4. And my 2x is going to be to the 1st power. And my negative 3 is going to be to the 3rd.
Wait, we're allowed to just write 2x.
Yes. I'm writing the degree so that you guys can see that the pattern is consistent.
So,
I am going to simplify this before we get.
question.
Yes.
When we put this in mathexcelforschool.com, more Candace.
We're going to simplify it. So let's do the next step together.
Okay.
We're not ready to input it anywhere because we've got stuff that needs to come together. So this is 1 times 2 to the 4th times x to the 4th. I'm distributing the power into the parentheses. When there's a plus, you can't distribute the power. But when there's a multiply or divide, we can distribute it.
We're still plussing, right?
Yep.
Plussing.
So here we have, I'm going to put all my numbers, I'm going to raise my numbers to the power they need to be. So this is 2 to the 3rd, x to the 3rd, and negative 3 to the 1 power is negative 3.
Wait, what Well, are we continuing? Are we?
I'm simplifying.
Oh, we're simplifying. So it's the same thing, but we're just it's a redo.
Right. So I got my 6, I got 2 squared, I got x squared, and negative 3 squared is negative 3 times negative 3. That is 9.
It's 9.
So here I have 4, 2 to the 1 is 2, x to the 1 is x, and negative 3 times negative 3 times negative 3 is negative 27. Negative 3 to the 4th power, if you're going to choose not to do this mentally and to put it in your calculator, parenthesis first, negative 3, close parenthesis, and then raise it to the 4th power. If you don't put it in your calculator right, it might give you out the wrong sign. So negative 3 to the 4th power is 81. Okay, we've got, I'm showing every single step. Once you guys become comfortable and familiar, there's things you can do the multiplication all in one step, but I'm not going to skip steps because I don't want to.
Oh my gosh, that's my whole life.
2 to the 4th power is 2 times 2 times 2 times 2, which is 2 times 2 is 4, times 2 is 8, times 2 is 16. So this is 16x to the 4th. 2 to the 3rd power is 8. I'm going to go ahead and move the negative 3 so it's grouping my numbers all together. I'm going to rewrite this here. 4 times 8 is 32. And then times negative 3 is negative 96. So I just multiplied these together to get negative 96. 6. 2 to the 2nd power is 4. And I'm going to move the 9 over so he's hanging out with just his number buddies. So 6 times 4 is 24. Times 9 is 216. Okay, and then 4 times 2 times negative 27, and then I'm putting the x over there. So 4 times 2 is 8.
160.
8 times 27 negative is negative 216.
I forgot the other.
And then thank goodness 81 we already did. So here is the final answer. If I'm putting it in Excel, but Canvas, it goes 16x caret 4 minus 96x caret 3 plus 216x caret 2 minus 216x plus 81. All right, take a moment, complete your summary. Please include all the revelations about Pascal's amazing triangle, how it's going to save us time in our distributing so we don't have to multiply out all those polynomials together. And have a good day.